Hello and welcome to another edition of the Integrated Science Intervention Program for SHS. Today's topic is electronics. In today's lesson, we will demonstrate how discrete electronic components behave in an electric circuit. My name is Kisiwa Edu and I'll be your facilitator. To get us started, do you recall these components below from our previous lesson? Well, which of them does the following? Store charges in a magnetic field, resist the flow of electrons, store charges in an electric field. Well done. Resistors resist the flow of electrons. Capacitors store charges in an electric field. Inductors store charges in a magnetic field. In our lesson today, we would learn to interpret circuit diagrams. Then we'll go on to relate to how circuit components behave in an electronic circuit, namely our resistors, capacitors, and inductors. So to start us off, we would interpret circuit diagrams. We'll demonstrate the effects of the electronic components as mentioned earlier as the lesson progresses. Some of the key words we will encounter in our lesson today are light emitting diode or LEDs, direct current or DC, alternating current or AC, series arrangement. Now when we talk about series arrangements of components in a circuit, it is when we put components end to end on a circuit. We connect from the positive side to the negative side. We would also see parallel arrangements of components. Now in the parallel arrangements, we put them side by side. What I mean by side by side is that in a parallel arrangement, all negatives go to one side and all positives go to another side. We will see connecting wires and a breadboard. Now let's begin by learning to interpret our circuit diagram. This is a typical circuit diagram you would find in your science textbooks. How do we translate this circuit diagram into the real diagrams that we see in our everyday electronic experiments? To start off, you have to pick a starting point. In this case, we would want to pick our battery as our starting point. The positive end of the battery, the black line you see there, is a wire that connects the positive end of the battery to one end of the resistor. The other end of the resistor is connected to the positive side of the LED, and the negative side of the LED connects back to the negative side of the battery, and that completes the loop. Now when we are done with this, this is how it looks like. Please join me as we have a practical section on how this circuit looks like. Welcome to our electronic working space. Just as we mentioned earlier, we are going to see how we put together a simple electronic circuit. To enable us do that, we have two dry cells. Now when we put the two cells together, we form a battery. We have a resistor, an LED, and some connecting wires. To create a battery, we are going to connect the negative end of one of the cells to the positive end of the other. This arrangement is a series arrangement. Now like we said, we look at our circuit diagram and pick a starting point. Our starting point for this circuit will be the battery. We are picking from the positive side of the battery. So we pick the positive side of the battery. I need to put in another connecting wire so that I'll be able to join the battery to the resistor. So from the positive end of the battery to one end of the resistor. The free end of the resistor goes to the positive end of the LED. Now the negative end of the LED goes back to the negative side of the battery, and there we have it. Our LED is glowing. So this is what I would call an already made circuit. So before we get here, how do people in the field of electronics plan out their circuit to get this? Let's have a look. This is what we call a breadboard. Now you can compare these two to the brown paper that seamstresses use to cut out the shape of dresses they want to sew. Now before we come out to build a circuit, we want to try out the arrangement of our component to see to it that everything works perfectly, and that is what we do with a breadboard. On this board you find a number of pinholes. All the holes to the horizontal are connected differently. The holes to the vertical are joined together, and therefore we do not put any two pins like this into the same vertical holes. If you want to put a component on the breadboard, you need to pick any point and you can spread it onto the horizontal like that. Now let's begin to build our circuit like we just saw. Again, I have my battery, my LED, and a resistor. So I'm going to put my LED onto the breadboard this way, and then I have to connect the LED in series to the resistor. So I pick the same vertical lead like that, and then I put it anywhere on the horizontal. My battery, one of the ends of the battery, so this one is the negative end of the battery, is going into the same vertical line on which one leg of the LED has been placed. The next part of the battery must also go to the same vertical line on which the resistor has been placed, and there we have it. Our components are working. So let's go back to what we would actually be doing in our lesson today. Now let's see how the resistor, capacitor, and inductor behave when they are placed in a circuit that has direct current as the voltage source. First, we look at the behavior of resistors. Now we have a circuit on the screen where a resistor is directly connected to
my mistake. No problem, starting.
So now let's see how resistors behave in a circuit. On your screen is a circuit where an LED is directly connected to a battery. So we are going to do that now. We have introduced a switch to the circuit. Please Carefully observe what happens to the LED immediately the circuit is closed. Now my switch is off, so I'm going to put it on to close the circuit. After some time, let's see what is happening to our LED. And there it is, the LED blows off. Now let's connect the resistor in series with an LED and connect it back to our battery. So we have another LED and then a resistor placed in series with it. Please observe and answer the questions that follow. We are going to put our switch on and please observe what happens. It's been approximately 15 seconds, just the same time it took for the other LED. But this LED still stays on. Please, what role did the resistor play in this circuit? Great. The resistor protects the LED in this case, and so the LED stays on. So we just witnessed one function of a resistor in a circuit as a protector. Now let's go back to the circuit that we started our lesson with. Please observe carefully the brightness of the LED. The resistor in this circuit is a 33 ohm resistor. Now we're going to change this with a 1000 ohm resistor. Observe what happens to the brightness of the LED. What can you say about the LED's brightness? So we see that the LED has grown dimmer. Can you explain what just happened? Well, let's have a short video to explain what happened when the resistor was changed to one of a higher resistance. Welcome back. So you see the higher resistance reduced the number of electrons that were flowing to the LED, thereby reducing the current, for which reason our LED looks dimmer. Now we move on to the next electronic component, the capacitor. Now let's put the capacitor in series with an LED that has been placed in series with a resistor. Please observe what happens to the LED when the circuit is closed. So you saw the LED came on in a flash. The circuit is opened. What happened to the LED? The LED is off. Now let's see how capacitors work in this short video. Welcome back. We are going to arrange the capacitor in a different way. This time the capacitor is arranged in parallel with the LED. What it means is that the negative end of the LED and the negative end of our capacitor are all joined together on the same vertical line. Because I cannot place my capacitor directly here, I use a connecting wire to connect from the negative end of the capacitor to the negative end of the LED. The positive end of the capacitor and the positive side of the LED are also joined together, and when we put all our negatives together and positives together on different sides, we say we have done a parallel arrangement. Now we connect our battery and see how our capacitor will behave. What happens to the LED? You see that the LED is on. We're going to put off our switch and make the circuit opened. Let's see what will happen to the LED. What role did the capacitor play? Well, let's see a short video and we'll come back to answer this question. Welcome back. So our capacitor stored up some charges, and after the key was opened, those charges moved through the capacitor into the LED and kept the LED on for some time. Now we want to see how inductors behave in a circuit. For the purpose of our lesson and understanding exactly what happens when an inductor is placed in a circuit, let's watch this video.
We get a very similar scenario when we connect an inductor in parallel with a resistive load such as a lamp. This is the same circuit as we just saw, but I've just wired it more neatly. When we power the circuit, the electrons are going to first flow through the lamp and power it. Very little current will flow through the inductor because of its resistance at first is too large. The resistance will reduce and allow more current to flow. Eventually, the inductor provides nearly no resistance, and so the electrons will prefer to take this path back to the power source rather than through the lamp, so the lamp will turn off. When we disconnect the power supply, the inductor is going to continue pushing electrons around in a loop and through the lamp until the resistance dissipates the energy.
Welcome back from my electronic workroom. Interesting, right? I hope you enjoyed as much as I did. So keep on getting curious. In school, talk to your teacher and continue to play with these electronic components and investigate how they behave in an electrical circuit. What have we learned in today's lesson? In today's lesson, we have learned to interpret circuit diagrams. We have also tried to see how resistors, capacitors, and inductors behave in an electronic circuit. For our task, we want to draw a circuit diagram for each of the following. First, a capacitor in series with an LED, a resistor, and a battery. Second, an inductor in series with a resistor, an LED, and a battery. I hope you enjoy doing this work. Till I come your way same time,